Good morning, everyone, and welcome to Whitmix's webinar, Design, Print, and Post-Process Splints using VeriSPLINT, 3Shape, Splint Studio, and Asiga printers. This morning we have Bryce Hiller who will be presenting the webinar. My name is Bernie Jaroslaw. I'm the marketing manager at Whitmix, and I'll be facilitating the webinar this morning. So I'd like to begin with a few housekeeping items. First, in the usually upper right-hand corner of your screen, you'll see a questions box. Feel free to use it. And if you have questions during the webinar, type them in. We'll see them at the end. And then at that moment, Bryce will answer all those questions that are printed there. Next, if you are a CDT, this webinar has been approved for 1 hour of CE credit towards your certification. That's scientific credit. You'll receive an email within 1 to 2 days that'll tell you exactly how to obtain that credit. It involves a very short, easy test, and you'll resubmit that to us. You'll get a certificate in the mail or email, and you'll be able to send that into the NBC. And lastly, the webinar is being recorded. Within 24 to 48 hours, it'll be up on the Whitmix website in the webinar section. So this morning I have the pleasure of introducing Bryce Hiller. Bryce has an associate's degree in information sciences from Indiana Wesleyan University and received his lab experience in his family lab, where he was instrumental in transitioning the lab from analog to digital. He's a digital support specialist at Whitmix in 3Shape design, 3D printing, and milling. Bryce has a passion for empowering dental professionals through education in digital technology. You're going to get a little taste of that now. So today, Bryce will be speaking on processing splints and how, if done properly, can impact your lab's bottom line. So that's about all I've got, Bryce. So if you're ready, let's talk about splints.
Awesome. Thanks, Bernie. Hi, everybody. Thanks for tuning in today. Looks like we've got 42 people, so that's pretty awesome. Thank you, everyone. So like Bernie said, today we're going to be talking about a few different things. We're going to be talking about our VeriSPLINT resin, 3Shape's new Splint Studio, and Asiga 3D printers. So what I want to do today is kind of give everybody kind of our official live, I guess, opening, ribbon cutting of the new Splint Studio. A lot of you may have already seen that it is actually released. I'm sorry?
Can't see the screen.
Oh, there's a screen. There we go. Anyway, a lot of you may have already seen that 3Shape has released the Splint Studio. Today we're going to actually kind of take a little dive into it and give a formal introduction into it. We're going to be talking about splints today, kind of in the Whitmix ecosystem, if you will. So as many of you may or may not be aware, these splints are classified as a Class 2 medical device per the FDA. So with that, the 510K clearance that comes with that kind of envelops an ecosystem, if you will, meaning it encompasses the CAD software, the resin, the printer, and the curing unit all as a system. So we're going to be talking about that quite in depth today. So let's go ahead and get started. Okay, so first let's talk about why splints. What can they do for you? Why, if you're not already doing these splints, why even dive into this? And we can also talk about, if you are doing splints analog, how transitioning these workflows digital can make a big impact on your laboratory or practice. The first reason that I like to encourage laboratories to learn how to digitally manufacture splints is how easy and quick it is to design these. If any of you had used the previous 3Shape Splint Designer, you're probably, I would say, painfully aware that the software was, and I'm being generous, it was a bit cumbersome. It was not very intuitive, kind of difficult to use and stumble through. You're going to see today that the new Splint Studio is excuse me, very efficient. It really just kind of, 3Shape kind of just scrapped the old software and they totally redesigned it. It's much more intuitive. It's much easier to get from point A to point B with 20 clicks, if you will. The next reason that you might want to consider splints is the ease of manufacturing. So these splints can be either printed or milled. We're going to talk about printing obviously today. And the printing manufacturing process on these is very simple. It's not hard to do. If you have a 3D printer, it's super easy to implement these. If you don't have a 3D printer, they're very easy to learn. Also increased profitability. If we have time at the end of this webinar, we're actually going to go through a little bit of nesting technique after you've designed your splint. And what we're going to calculate is how much it's actually going to cost to manufacture it. It's probably going to be around $5, $5 to $7 or $8 to print our splint. That's a very low manufacturing cost relatively, and depending on your market, you might get anywhere from $100 to $200 for a splint, night guard, etc. So there's a lot of profitability here for laboratories, which is always a plus. And also finally, you can simply increase your lab's offering. So you can make your laboratory more appealing to a wider range of doctors and practices. The more you can offer them, the more benefit there is for them to send to you. So that's also a really big key point as to why you might want to consider diving into splints. So we're going to talk about some of the in-house equipment that you're going to need. The first being 3Shape, the second being a 3D printer, preferably our Asiga Max. And you're going to need the resin. As you can see towards the bottom of the screen, we're going to be talking about the VeriSPLINT OS resin today. And finally, you're going to need a curing unit that is not pictured here, but the curing unit that we will be talking about is the auto flash. The workflow that we're going to go through today is scan, design, print. We're not actually going to scan today. We're going to import some previously scanned master casts. But we are going to go through design and printing. We're going to talk about design and printing in the context of our own WhipMix ecosystem. So we're going to be designing in 3Shape Splint Studio. We're going to be nesting and talking about printing on the Asiga Max UV385 printer. Real quick, let's get some of the kind of technical information out of the way. So you might be asking yourself, so I have 3Shape, can I use Splint Studio? Or you might be asking yourself, okay, I don't have 3Shape, what do I need to get? What do I need to purchase to be able to use the new Splint Studio? So there's really three options here. Dental System Complete Restorative and Dental System Premium both will have the Splint Designer module included. So if you have either of those or you purchase either of those, you're going to be all set. Let's say you only have the Dental System Crown and Bridge package. That's okay. You can actually add on the Splint Design module, which will get you full access to the 3Shape Splint Studio. So you have three options here. They're all at different price points. And if you don't already have 3Shape, I recommend looking at each of these to try to determine what is going to best suit your laboratory. First, let's talk about some different scanning options. So really, we've got two main options here to actually gather our data that's necessary for producing these splints. The first is going to be an intraoral scanner. So you absolutely can receive scan files from an intraoral scanner and import those and use those to produce your splint. The second option is going to be a desktop scanner like the 3Shape E4, E3, or the 3Shape E series. Is also the other preferred method for receiving these scans. So I do want to point out, in case for any of you that didn't already know, so the new Splint Studio is actually kind of housed within 3Shape's Dental Desktop. If you're not already familiar with Dental Desktop, This is a separate software from your regular dental system, and it houses things like Implant Studio, for example, Smile Designer, and now Splint Studio. So the Splint Studio is its own module within Dental Desktop, which we're going to get into momentarily. Real quick, let's talk about the printing aspect. So today we're going to be discussing the Asiga Max UV385 with the VeriSPLINT resin in the Auto Flash Cure unit. So let's get into 3Shape now. So one nice thing about Splint Studio, even though it is contained within Dental Desktop, you can link it to your regular 3Shape Dental Manager. We're not going to go over how to do that today. It's technical, and that's kind of our job, not necessarily your job. As long as we are your reseller, that's kind of our job to take care of for you. So what we're going to do is we're going to start with a new order. So we're just going to name this, we'll just call it Splint Test. We're going to be importing from a digital impression today. And now I'm going to first select a second molar. On the maxillary, select the corresponding second molar. We're going to scroll down here to Appliance. And then instead of clicking Scan, we're going to click OK. So here's our new order. We're going to right click. I'm going to go to Import Scan. And here I already have our scans located in a folder on my desktop. So first, you always want to check and make sure that you're aware of which scan it's asking for first. This is a big kind of oversight that new 3Shape users will make. So right now it is asking for the upper jaw. So we're going to select maxillary. Now antagonist, we're going to select the mandibulary. That's funny. Okay, so now you can see down here we have our scans, and we're ready to go into design. So I'm going to right click again, and since I have linked Dental Desktop in the Splint Studio to our Dental Manager, this button is here. If you have not linked it, this method won't work, and you'll have to actually order it in Dental Desktop. Now, the 3Shape Dental Desktop, if you already have 3Shape and installed it, Dental Desktop will more than likely be installed on your PC. However, that doesn't necessarily mean that Splint Studio will be installed. So what you may need to do, if we are your reseller, call us, and we can actually manually download and install Splint Studio, but it won't necessarily be installed by default. As for the technical requirements for this software, it's going to be the same as regular dental system and dental desktop for Splint Studio. Same PC technical recommendations. Okay, so here we are in our Splint Studio. So if you've used 3Shape before, you're going to already be aware that up here on the top of our screen are our various steps that we have to go through from start to finish. And over here on the left side of the screen are going to be any sub-steps that are required, or the step that we're actually on. One nice thing about Splint Studio is up here in big black letters. It's going to tell us exactly what the software wants us to do. Click where the mesial and incisal edges meet on the incisors, and then click the mesial lingual cusp tip on tooth number 14. It's going to set that occlusal plane. Looks good. The other thing you may need to do over here under machine and material, you may need to select a 3D printer and corresponding resin. For the purposes of today, and more than likely if you're going to use the Splint Studio, we're just going to select the Formlabs Form 2. This really is inconsequential, and there isn't really anything between these that's going to change a whole lot. So we're just going to select the Form 2 option. I'm going to go next. Okay, so now we are in the byte configuration phase. You can see up here, the highlighted step is byte configuration. So what we want to do now is we need to make space for our splint, because right now we just have a closed byte. So we need to actually open this byte to accommodate our occlusal appliance. So the best way to do this is to open the splint to a specified posterior thickness. For our VeriSPLINT resin, our recommended posterior thickness is going to be 2 millimeters. So right now, we already have 2 millimeters entered into this field. I'm going to click the open button here, and it's going to open the byte based on how our minimal posterior thickness. To lock this as our byte, I'm going to click the lock button. Now, different resins are going to have different minimal thickness recommendations. 2 millimeters in the posterior just happens to be ours. I'll then click next. So the next phase here is insertion direction and blocking out. So it's going to, by default, give you, as you can see based on this green arrow, an exact occlusal insertion direction. If you like, you can change this. The best way to do that is to find an occlusal view that you like for the insertion direction, and then you can select the From View button. And then you will see, after it's done calculating, it will actually update this color map, which is a kind of a visual representation of your blockout wax, or where your blockout wax is going to be. Some other options down here, you can tell the software here if you even want to block anything out. If you don't, you will unselect that, and there will be no blockout wax applied. You can also specify the blockout angle. So the angle at which you want to block out these undercuts. It's going to default to 0 degrees. You can increase that, I believe, all the way up to probably 10 degrees is going to be the maximum that you can set that. We're going to leave this at 0 today. And finally, you can set a custom retention amount. So what this retention amount is going to do, let's leave it at 0 and let it calculate. And you're going to see it's going to basically block out all of the undercuts, all the way up to here. So you can see, if we turn on the blocking out, we've got blockout wax encompassing almost all of the undercuts. If we gradually increase that retention amount, it's going to reduce that blockout wax. And what you can do, there's a couple different ways that you can kind of make sure that you have the proper retention for your splint. You can either use this retention setting and increase this until you have the desired blockout wax. Or we can set it to 0. And then in the next step, we can actually just manually sculpt that blockout wax. So here in this phase, we can actually sculpt on this pink blockout wax. We have a wax knife tool that if you've used 3Shape before, you're intimately familiar with. If you haven't, we have 3 tools here. We have Add, Remove, and Smooth. We can change the size of that circle. So I'm holding Shift and using my scroll wheel. And we can also affect the strength or intensity of that wax knife. And you can modify that by either clicking and dragging here, or if you push and hold your control key and use your scroll wheel, you can change it that way as well. So in this phase, what you can do, we can use our remove tool, and we can remove this blockout wax manually to accommodate our desired retention. I'm gonna check questions real quick just to see if we have anything that has come in. Guys, feel free to ask questions. We don't have to wait to the end. I'll check it periodically just to see if anybody has anything in regards to the current step that we're on. So feel free to ask away. So once we have finished with our blockout wax, our sculpting, I'm going to select next. So now we're going to actually draw the outline of our splint. There are some design settings over here on the left-hand side that we're going to talk about. The first one is splint thickness. So this is going to be the base occlusal thickness of your splint. The minimum thickness is the overall minimal thickness of the splint, including the buccal and lingual walls. Offset from teeth to splint. This is essentially your cement gap, if you will, even though obviously we're not using any kind of cement. It's the space, the allowable space in between your appliance and your actual patient's teeth. Drill diameter. This is going to be if it's going to be 0 if you're 3D printing. What this is, if you're already using 3Shape, this is essentially your drill radius for your milling manufacturing process. If you're not familiar with 3Shape yet, what this is going to do is it's basically going to round out any internal sharp corners to allow for a physical milling tool to reach those areas so that it will actually fit. But again, today we're 3D printing, so we're going to leave this at 0. We don't need any kind of drill diameter. So on the VeriSPLINT resin, we're going to leave. I'm going to bump up both of these values to 2 millimeters. And to draw our line, you can do single clicks, like so, or you can actually just click and drag. So I'm not going to really get into, for the purposes of today's course, I'm not going to spend really much time at all on proper splint design. That's a whole nother conversation that we definitely can't do in 45 minutes. So the purpose of today is to simply demonstrate the function of the software and an overview of the manufacturing process. So I'm just going to do this very quickly. And to finish our outline, I'm going to click on the original point that we created. You can then come back and make any corrections by simply clicking and dragging. And then once I've completed my spline line, I'm going to click next. All right, so this is where we really begin the functional design of our splint. So we are up here in our raised surface step. So we have 3 options here to create our initial splint design. The first one is going to be raised to antagonist cusp tips. So what this is going to do is going to analyze the antagonist arch, and it's going to raise the splint basically to accommodate all of the antagonist cusps. The second option here is to raise to antagonist plane. So it's essentially going to analyze the antagonist, create essentially a flat plane based on that antagonist arch, and it's going to raise your splint occlusal surface to that flat plane. The third option here is going to be raise ramp. So this is what you would want to use for any kind of canine or anterior guidance. The nice thing is that you can combine any and all of these options. So for example, let's say our posterior teeth, I want to raise to antagonist cusp tips. Let's turn off the preview here. And then let's say for our canines and anteriors, I want to implement a raised ramp for guidance. So you can see we can combine these options to accommodate the specific function that we're looking for. So this is what I'm going to do for right now. I'm going to go with this design, and then I'm going to select next. Let's see, it looks like we have a question. Is there a default articulator type? Oh, hi, Tom. Let's see. So the default articulator, let's get back here, is going to be the Artex articulator. In other aspects of dental system, there are more options. These are the only ones in Splint Studio for now. I would highly anticipate more being added. So I hope that Tom answers your question. All right, so let's skip back forward. Okay, so we have our initial proposal here for our splint. Over here on the right-hand side of your screen, you can toggle on and off various aspects of your case. So we can toggle on and off the antagonist, we can toggle on and off the preparation scan, and we can even toggle on and off the actual splint itself. So here we've got a little notification. The design is 0.5 millimeters thinner than the recommended 2 millimeter material thickness. Do we want to correct this action, or do we want to accept? I'm going to go ahead and click correct for the time being. So if we turn on our antagonist, we can see, just as we specified, the Splint Studio created in the posterior, it raised a splint to accommodate those antagonist cusp tips. And then on the anterior, we have a raised ramp to allow for canine and anterior guidance. So here's where we're going to finalize our design. First, we have our wax knife, where we can add material, remove material, and smooth. Typically, I'll just come in here and I'll smooth some of these surfaces out a little bit. Just make it kind of look pretty, if you will. So the other thing that we can do here in this final adapt design option is down here we have some articulator options. There's some really cool features here that we can do. We can simply run our virtual articulation. We can see where our contact points are. So these blue areas here, 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 all these little blue splotchy areas, these are where we are making contact in our excursive movements. So you can see we have canine and anterior guidance here, and we have also some contact back here in the posterior. What we can also do down here at the bottom, we have some adapt design options. The first one is going to adapt the design using the full motion of the jaw. So it's going to analyze those excursive movements, and it's going to adjust our design based on those. So now if we go ahead and we run our virtual articulator again, you can see there's far less contact, especially in the anterior. Now, however, let's say for a minute that you only want to reduce areas in the posterior. You want to preserve those anterior ramps for anterior guidance. What we can actually do is we can click down here in the bottom left-hand corner. We can click this adapt design option down here. This enables us to lock specific areas of our splint and prevent them from adapting when we run the adapt design button. So to do that, I'm going to select that option. Now it's highlighted, and I'm going to highlight the areas that I want to preserve. Now when I run the adapt designs button, it is not going to adapt any of those areas. So this is a really nice customization option to really design the splint based on your specific patient and or doctor's request and or needs. Again, we have some more, if we click this gear icon, we have some more virtual articulator settings. And again, all we have as far as options is going to be the Artex articulator. So in this step, we're going to essentially finalize our design. And again, those of you that have used the Splint Designer in the past, you're probably kind of amazed how much more simple this process is than the Splint designer in the past. It really reduces this process from quite frankly, a 30 to 40 minute design down to probably 5 minutes, 5 minutes of design on these splints to get from point A to point B. If you're scanning it in with your desktop scanner, add another few minutes on there for your scan time, and that's it. You can really have these designed and exported, ready for manufacturing, and realistically, once you're proficient with the software, anywhere between 5 and 10, 12, 13 minutes. It's very, very quick. Some other options, some other tools over here on the right-hand side of the screen that we have. We have a distance map. So this is going to show us essentially distance to our antagonist. So obviously the red areas are going to be contact or approaching contact, and the yellow working your way down to green are going to be farther out of contact. So this can be a useful tool if you're really paying super close attention to your occlusal contact. And finally, down here at the bottom, the last option, we have minimal thickness. We can toggle this on, and it's going to show us in red. So right here, you can see it's going to show us areas that are below our indicated minimum thickness. It's up to you. It's up to your discretion if you want to come back and thicken those up at all. I always recommend following the manufacturer's specifications on whatever resin you're using, if they have any. And again, on the VeriSPLINT, ours is 2 millimeters. Okay, so let's just, let's say that this is our final design. All we have to do at this point is click next up here. Dental Desktop / Splint Studio is going to automatically close, and it's going to export that file. Here's our case. Let's go ahead and open. I'm sorry, wrong button. Go ahead and open our manufacturing directory. And here we have our Splint file. So this is ready at this point to go to either the your nesting software or your CAM software for your mill. Check questions. Anybody have any questions at this point? I'll just wait just a minute and see if there's anything that comes in. 3Shape definitely made this new Splint Studio essentially dummy proof. It's almost impossible to mess it up really in terms of the actual software. The previous Splint designer, it was easy to get strange errors and warnings and all kinds of issues in the software itself. I haven't really stumbled across that yet. Okay, a couple questions from Sergey. Could your resin be adopted to work with Culzer's Cara printer? If yes, how do you do it? Thank you. Probably not, to be quite frank. The Cara print printer from Culzer, they lock it down pretty tight. It's not something that we would necessarily be able to support, simply because we're not willing to backdoor other people's printers. You might want to call your Cara printer either tech support or sales rep to get that kind of information. However, you do need to keep in mind that even if you do find a way to print on that printer, you are going outside of that 510K clearance. So just to reiterate, this FDA clearance, this 510K clearance for a Class 2 medical device is kind of enveloped and encased in an ecosystem. So if you take our resin, which is technically 510K, into another printer, which might also be 510K, but those don't fall under the same ecosystem, you have not manufactured a 510K cleared device. Okay, so let's go. Let's see here. Why did you select 0.1 millimeter space between the materials and the teeth? Let me expand this a little bit. What happens when 0 is selected? So 0.1 millimeter. So yeah, let me reread the question. So why did you select 0.1 millimeter space between the materials and the teeth? What happens when 0 is selected? Short answer is you're just going to have essentially more retention. It's going to be a tighter fit. 0.1 millimeters is the default, so you're going to have 100 microns of space in between your splint and your teeth. If you select 0, there's going to be no space. So it's going to be a tighter fit. This is something that I recommend playing around with a little bit. One of those things that oftentimes comes down to preference. Preference for the patient's preference, doctor's preference, etc. If you want to start with 0.1, print a couple splints, test the fit, see what the patient thinks. That's a good place to start. If they feel that it's too loose of a fit, then you can reduce that to 0, and it's going to make that fit tighter. Let's see. Hi, do you know how long the VeriSPLINT lasts? It is very brittle. I'm not sure how long it will last. Well, it's a class 2 medical device, so it's going to be longer than a year. I can definitely say that. In terms of longevity, it's hard to say because it's we don't have data on that yet. Is the short answer. This resin has been out for less than a year at this point, so we don't have any kind of long-term data yet. Well, time will tell in terms of how long it's actually going to last in the mouth. Let's see here, moving on. Suggested option for an ID tag. Yeah, it's one of the features that I wish they had added into the Splint Studio would be an ID tag. You could use a third-party software, maybe like Mesh Mixer, to add an ID tag if you're familiar with that software. We're not going to dive into that just because there's much steeper learning curve for Mesh Mixer than there is for Splint Studio. When I have been designing, I've noticed that the antagonist model goes through the ramp instead of, let's see. When I've been designing, I've noticed that the antagonist model goes through the ramp instead of using the ramp to disclude on the posterior. Is there a way to make the splint solid? So what it sounds like you're not opening the bite in that very first step to accommodate that minimal thickness. That sounds like that's what's happening. One thing I've seen happen often that that people forget to do, and I'll actually demonstrate it. Let's go ahead and reopen our Splint Studio. Okay, so one mistake I've seen people make so far is they will open their bite and forget to lock it. If you don't press this lock button, you're going to move on. It's not going to save your open bite. I've had several calls on that question. But as long as you lock that bite, your antagonist model should never go through the ramp. If it does, you can use the technique that I showed you towards the end of the design, where you can mark specific areas to lock and prevent from adapting to design. For Megan, I always lock and open to at least 2.5 millimeters and then thickness to 1.8. Yeah, that's fine. If you lock and open your bite to accommodate 2.5 millimeters and set your minimum thickness to 1.8, that's fine. That's no big deal. That will work. How would we adapt for a hard soft reline? From Jake. I'm not entirely sure what you mean, Jake. If you could kind of elaborate a little bit for me, I might be able to give you an answer on that. So we'll wait just a minute. Okay, so at this point, we went ahead and we exported our splint, right? So now you might be thinking, well, what do we do now? I need to print it. So I'm gonna quickly show you a couple little tips for printing this in Asiga Composer, and we will actually go ahead and calculate the cost on it as well. So for those of you that use Asiga Composer, have an Asiga printer already, this is going to look familiar. For those of you that don't, I'm just going to real quickly show you how easy it is to nest and print these. So I'm going to click a new print job. I'm going to go to VeriSPLINT. We're going to print at 50 microns. So let's add our splint. So voila, there's our splint. It's actually not the one we designed, but it'll work. So a couple tips. I always print on the occlusal surface rather than like the intaglio surface, simply because it's a lot harder to remove supports, and I'd be concerned about fit if you missed one. So I'm actually going to go ahead and flip this over. Like so. I'm going to bring it pretty far down close to the build plate. I'm going to go ahead and automatically apply our supports. And this is ready to send. So a couple notes here that are remarks that I would like to make. I do not recommend printing these vertically. It might be tempting if you're needing to print, like 7 splints. However, we have noticed that for some reason, when you print splints vertically, they tend to not fit. They tend to be way too tight, and you might not even be able to get them seated in the mouth. I haven't been able to figure out why that is. And I don't think it's unique to the Asiga printer. I think it's kind of the nature of DLP printers all around. So we definitely recommend printing these horizontally. And if you do print them horizontally like this, honestly, you can still fit 2 splints, and this print job is going to take, probably 30 to 35 minutes. You can print them at like a 45-degree angle. That'll be okay too. We haven't had issues with that. It's just when you print them perfectly, like perfectly vertical, or close to vertical, that we've seen issues. So let's go ahead and let's see how much this is actually going to cost us, because that's obviously a big factor here is profitability. So down here, or up here in the build time calculator, we have a handy little tool. I'm trying to think of what the price on this resin is. Bernie, do you know how much we charge for this resin? I think it's $420.
I think it's 400.
400? Whoa, that's not right. So this splint, including the supports and everything, is going to cost you $3.64 to print. It's pretty awesome. And let's go ahead and calculate our build time. Our printer's not on. Let's go ahead and just ignore. So right now we're at 43 minutes. However, if I updated this software and selected the fast print mode, which would be right here, that number is probably going to be reduced to about 35 minutes, which is super fast. You can print 2 to 3 splints in 35 minutes. That's a pretty good deal in my book. And I would print these with a base plate. right here. I usually do 300 or 400 micron base plate, simply because the more surface area you're printing directly on the build plate, the better adhesion you're going to get, the less chance it's going to fall off. So I do recommend printing with that base plate. Okay, so let's see if there are more questions. Any questions about the 3D printing aspect? We'll quickly go over the post processing, so the alcohol wash and the curing. But before we do that, I'm just going to wait and see just for a sec to see if there's any more questions that come in. Can you show the cost calculator one more time? Yeah, absolutely. That's right up here on your toolbar. It actually says build time calculator because it does have a build time calculator. However, that doesn't, it's kind of an outdated feature due to the new fast print mode. But down here at the bottom of this window, there is a material rate and material cost. So you enter the price per liter, and then it's going to tell you how much you're going to spend to print this. That was from Justin. What's up, man? All right, no more questions at this point. Okay, so so let's talk about post-processing and final cure. So post-processing, in terms of alcohol wash, it's just going to be like anything else. You're going to do 5 minutes in a dirty bath in an ultrasonic, and then 5 minutes in a clean bath in the ultrasonic, just like any other object that you 3D print. Now the curing on clear resins can always be a little tricky because the tendency is for UV light to want to cloud up these resins. So what you're going to notice after you when your splint is sitting on the build plate finished in your printer, it's going to look nice and clear. You're going to run it through the alcohol. You're going to pull it out and you're going to say, what the heck? Why is it so cloudy? Because it's going to be cloudy. The cloudiness you can eliminate by doing just your typical pumice and polish. You can really get these very, very clear. That cloudiness is really just on the surface. It's not on the internal printed material. It's just on the surface. As for the final cure, the unit that I recommend is the Auto Flash. Some of you might already have it. We've sold this curing unit for a number of years now. It's a really nice curing unit, and we recommend 6,000 flashes in your Auto Flash. And what you're going to notice when you bring it out, it's going to have just a little bit of a yellow color to it. This actually does subside over time. So if you take that splint out, you pumice it, you polish it, and you let it sit for a couple of days, that yellow tint is going to reduce quite a bit, and will continue to do so even for a year or longer. That discoloring lessens over time. Now, a question I get a lot is, well, I don't have an Auto Flash, I have a Uvatron, because a lot of people use the Uvatron for their digital dentures, because that's the indicated curing unit for the Dentka resin. We have found more discoloring in the Uvatron, simply because it is a much more intense light source. The light source is more intense and it's hotter. So the combination of heat and UV light are what's going to cause that discoloring. So if you use the Uvatron, we're recommending 4 minutes in the Uvatron. Again, take it out. It's going to look it's going to have a yellowish green shade to it. Pumice, polish, let it sit for a few days if you have the time. Otherwise, or just give it to the patient and let them know, like, hey, just wait a few days, it's going to clear up. And that discoloring will subside, just like the Uvatron. Does curing under nitrogen affect the fit? Not to my knowledge. However, you don't need to cure under nitrogen in the Auto Flash. Let's see if we get any more questions. We're just about done. We're kind of right at that 50-minute mark. So I do want to take just a couple minutes here And if anybody has any questions, now's the time to ask. If you think of any questions after the webinar, feel free to reach out to me. This week's a little crazy because of Chicago. Hopefully I'll see a bunch of you there. Feel free to come by the booth, say hi, introduce yourself if we haven't met before. So I'll just wait a couple minutes here for some questions to come in. What's the recommendation for storage of appliances by PT patient? Do you store in water or just dry in a container? Basically, I usually recommend treat it like a denture. Clean it, brush it. Don't eat with it in. Don't go don't go tanning with your mouth open with your splint in. Just basically treat it like you would treat your denture in terms of storage. Throughout the day, don't drink alcohol, don't smoke with it in, don't eat. Smoking is definitely going to discolor it severely. So, I mean, seems like common sense. In terms of storage, treat it as a denture. You definitely want to brush it, keep it clean. You can store it in water. How do you take off these support pins? It's a great question, Ted. So usually what I will do first is after you've done your alcohol wash, I will actually just kind of pinch the supports to take them off. The VeriSPLINT resin, the supports come off very easily. Yeah, I will simply just pinch them to pull off the bulk of the support. Then typically I'll use like an oval carbide burr if there's any bulk left on any of the support areas. But you want to be very careful if you're going to use that carbide burr because obviously we don't want to alter our occlusion. And finally, the last thing I'll use is we sell these little Scotch-Brite rotary brushes that work phenomenally for 3D printed support removal. I'll use typically either a medium or coarse grit Scotch-Brite brush in my handpiece and smooth out the remaining support areas with that. Good question, Ted. Can you print a hard soft splint? Yes, it is something that I've experimented with. It is not by any means something that I would recommend at this time. I've done it strictly for experimentation, but there is no hard soft splint specific resin. There is no hard soft splint process that's approved by any manufacturer or certainly the FDA. I would maybe wait a couple of years, and I'm hoping that we're going to have a hard soft option on the market. Will reducing the amount of flashes affect the yellowing / reduce strength? Yes and yes. It will reduce the yellowing, and it will also reduce your strength. Good question, Justin. Megan, I use both KeySplint and VeriSPLINT and noticed that the inside can get gummy when steam clean. Is there a reason for this? How to avoid the gumminess? So are you, as a follow-up question, are you getting that on both resins or just one or the other? Would it be better to print with less supports to reduce the margin for error? You know, you can. If you automatically apply your supports and then start removing them, you do have to be careful because if there's any islands, so we call them islands, and what those are freestanding areas that are being printed in midair. Any of those areas have to have a support. If you remove a support on an island, you're going to have a failure. So if you're going to start removing supports, I would make sure that you're intimately aware of where those supports are located, and I would probably scroll through slice by slice to make sure that you're not removing a support on a critical area. Will I be able to get the recording from you today via email? I believe within 24 to 48 hours, it will be uploaded. The entire webinar will be uploaded onto our website. Megan, on both, and when trimming / adjusting it if it needs it. So it's feeling gummy. I would take a look at your curing process. If you don't mind commenting again, let me know what your curing process is, exactly what unit you're using, how long, and I might be able to give you a better answer. Gina, can I cure it with the same UV light I have for my VeriModel OS, or is that extended UV exposure what you meant makes it cloudy? So what UV light are you using for your VeriModel OS? If you're using the little Asiga flash unit, that will not be sufficient for your splints. Not only will it not cure the material to the proper recommendations, but it's also not going to be a 510K cleared appliance. Using the recommended curing protocol with the auto flash from Megan. Okay, so Megan's question is she's using both the key splint and the VeriSPLINT resins, and she's noticing the inside can get quote unquote gummy when steam cleaned. Is there a reason for this, and how to avoid the gumminess? And it's happening on both resins and when trimming and adjusting the fit if it needs it. You know, that's a tough one because I've not encountered that personally. Sounds like it has something to do with the steam cleaning. You know, I'm not sure if these are indicated for steam cleaning or not. I will need to check with our chemist. So let's do this. After the webinar, I will check with the chemist, and if you guys are friends with me on Facebook, I'll comment. I have a link that I just shared today for this webinar. I'll comment on that link. So add me on Facebook, Bryce Hiller, and I'll comment on there if I can see if our chemist has encountered that with steam cleaning. What percentage, if any, is the shrinkage factor? So there's definitely going to be shrinkage. However, it is compensated for in the INI file. So the INI file is the specific resin profile that you use in Asiga Composer when you're printing these splints. So the shrinkage factor is compensated for already in that INI file. Let's see if there's any more coming in. Just wait a few seconds here. Oh, there's one. What is the recommended time for the Sunray 400 for a splint? That's 4 minutes. Could you use the auto flash for dentures? You know, you theoretically could. The key is with dentures, with the Denka resin, is you need to make sure you cure it in glycerin. If you can fit glycerin in the auto flash in like a little container, you know, possibly. Again, though, you want to be aware of that 510K clearance. That is not an actual 510K approved curing unit for the Denka resins, to my knowledge. Delmar, 4 minutes seems to be too much. No, that's 4 minutes is what we found to be sufficient and comparable to the auto flash. Delmar again, it makes them too dark and hard. Can we do 2 minutes? You know, you can experiment, you can do 2 minutes, although we cannot guarantee that it won't break or that it's going to function properly. But like I said before, the auto flash is definitely the recommended curing unit. All right, last call. Give you about 10 seconds. Get those questions in if you have any. All right, Justin. All right, well, that's all I've got for today. I hope this was helpful. Feel free to reach out to me with any further questions. I just wanted to give everybody kind of a brief overview today of the Splint Studio software. So I hope this was helpful. Thank you so much, everybody, for attending. I hope this was good for you.
Yeah, thanks everybody. I really appreciate your being with us. Just a reminder, this has been recorded, so if you want to see this or any of your peers missed it today, you can, plus you can review it for your CDT credit. It will be up on the WhipMix website probably by tomorrow in the webinar section, and of course in the 3D printing section of that. Those of you who are CDTs, you will be notified within a day or so, and you will have a small test to fill out just to see if you're paying attention, and we'll submit it and we'll send you the a certificate. You can send it to the NBC. So once again, thanks so much, Bryce. Thank you very much. Great job as always, and thanks all of you for attending, and see you at the next WhipMix webinar.